So this is actually a doable question. So let's analyze how to approach this question. Okay. On Jan 1st, a person saved 1 rupees. So let's say this is Jan 1st, a person saved 1 rupee. On Jan 2nd, he saved 2 rupees more than the previous day. So previous day he saved 1. So 2 more, it's going to be 3 rupees. Okay. On Jan 2nd. And on Jan 3rd, he saved 2 more than the previous day. So 2 more than means the previous day it's 3, 2 more than that 5, and so on. So on Jan 4th, it's going to be 2 more than, it's going to be 7, goes on like that. This is the series you are getting. And end of which date? So I need to find at end of which date versus total saving. So total saving means you add all of them up. Okay. So total saving is a perfect square as well as a perfect cube. So challenging part would be to find out which number is going to be a perfect square as well as a perfect cube. The first number that comes to your mind is 1. 1 is a perfect square as well as a perfect cube, but that will not work here. That means he just saved only 1 rupees. That's not possible, right? So next number is going to be 64 is that number, 64. So 64 is nothing but 4 square is 64. Sorry, 8 square is 64. As well as 4 cube is also 64. So 64 is actually a perfect square as well as a perfect cube. So that means until which date, so I need to follow until which date the sum is going to be 64. That's what we're going to do. So the best way to solve is you can use back solving approach. Okay, you start with the smallest date and check whether that is going to be your answer. The sum is going to be equal to 64 or not. Because these are not like far, right? It's 7. You need to add 7 numbers, right? It's not that far. So it's easy to do it. So let's say on the 5th day, it's going to be, let's start with option A. I'm checking this is going to be right answer or not. On the 5th day, he's going to save 9. And on the 6th day, he will be saving 11. And on the 7th day, he will be saving 13. Okay. So I'm going to check whether the sum is going to be equal to 64 or not. And when you add them up, you can see a pattern here, right? So it's going to be, so there are 2 ways you can solve it. You can add them up or you can use the formula for taking the sum. It's up to you. So if you're adding them up, you can see a pattern. See, 11 plus 9 is 20. This is also going to be 20, right? 7 plus 13 is 20. So you have 40 here. Then 5 plus 3 is 8. 8 plus 1, 9. It's going to be 49. So which is not equal to 64. So you can eliminate option A. Now let's try option B, one more day. So on the 8th day, you have 15. He'll be saving 15 more. So the sum is going to be equal to 64. It makes sense. Right? On the 8th day, he's saving 15 more. 2 more than the previous day. 13 was the previous day saving. 2 more than that, 15. So on the 8th day, the total saving is going to be 49 plus 15, which is 64. Which is a perfect square as well as a perfect cube. So you can stop at that stage. So your answer is going to be option B is the right answer. 8th January is the right answer here. So another approach you could use in this question is you can use the formulas of arithmetic series. Right? This is because you can easily figure out that this is an arithmetic series, right? First term is 1 and the second term is 3. Then 5 goes on like that. And we need to find how many, when is going to be the sum is equal to 64. That's what I need to find. So if you remember the sum of the n terms in arithmetic series, how do you calculate the formula is n by 2 times 2a plus n minus 1 times d. This is going to be the sum which is equal to 64. So n is the number of terms and a is the first term in the series and d is the common difference, right? The common difference is 2. Each 2 consecutive terms, if you take, the common difference is 2. You can also use the formula. First approach is much better because it's very simple and something you can easily apply. And if you are comfortable with the formulas, let's say if the dates are bigger. For example, this 7, 8, 9 is very close to Jan 1st. So first approach works in this case. Let's say if it was a bigger sum as well as the dates are far further. So it's not practically possible to list down all the values, right? So in that situation, you could use this form. So instead of n by 2 times, instead of a, you can put the value of a is equal to 1. That's the first term. A is the first term, and the difference, the common difference is 2. So it's going to be 2 plus n minus 1 times 2. This has to be equal to 64. So it's going to be n by 2 times 2 plus 2n minus 2. This 2 will get cancelled. Is equal to 64. If I simplify it further, it's going to be n times 2n by 2 is 64. Or I could say n square is equal to 64, or n is equal to 8. So that means there should be 8 terms in the series. So that sum is 64. 8 terms means the last or the end date is going to be 8th January. So you can use that to get to the answer. 8th January is the right answer. So this is also another approach you could use.